Homework 65, the solubility with the common ion. Number one, we are going to compare the solubility of barium sulfate. Okay. The solubility of barium sulfate in pure water. Okay. And then in the presence of barium nitrate. So if it is in pure water, if this barium sulfate in dissolve in pure water, it will ionize, dissolve to produce the barium cation and then sulfate cation. Okay, so let's say that it dissolve X and X because the mole ratio is 1 to 1. So the KSP is given to you 1.1 times 10 to negative 10 is going to be equal to the concentration of barium multiplied by the concentration of sulfate. So if you want to know the solubility of barium sulfate, you just have to square root the KSP, and the solubility in pure water is 1 times 10 to the negative 5. Now, on the other hand, if you try to dissolve this barium sulfate in the solution that already have barium ion in it, the source of the barium ion is the barium nitrate. Now, because you know nitrates dissolve in water very well, if you throw in 0.01 molar of barium nitrate, all of it will dissolve. It will give you the barium ion to begin with. So now, when you try to dissolve barium sulfate, okay, which doesn't dissolve in water very well, in the solution that already have barium nitrate, okay, so you are trying to dissolve this in the presence of some of that barium solution that already have barium in it. So it would not, the barium sulfate would not dissolve as well as it is in the pure water. So you're going to have X, okay, and this is X. Of course, this X is going to be the less than this X. So now let's try to solve for the solubility of barium sulfate in the solution that already have barium ion in it. Solve for the X. Now we can assume this X is very small because the KSP is very small. So this assumed to be equal to 0. Now solve for X. So it's going to be the KSP divided by 0.01. So you can see that the solubility of barium sulfate is very, very small compared to when barium sulfate dissolves in pure water. Now this one is, number 2 is similar to number 1. You're looking at the solubility of silver bromide in pure water and in the presence in compare this in the solution that already have some bromide ion in it. So if you dissolve silver bromide in pure water, it will dissolve and giving you X mole of silver and X mole of bromide. If you want to find the solubility, you just have to plug this value in the KSP expression and then solve for X, and that X represents solubility of the salt. Now, if you're dissolving this silver bromide in the solution that already have some bromide ion in it, how much bromide? So you can find that out. Divide the 0.15 by the molar mass of sodium bromide. Per every 1 mole of sodium bromide give you 1 mole bromide, and divide that by the total volume of the solution. So this is the concentration of the bromide ion. Okay, so now this is the KSP. Okay, this is the concentration of bromide ion at the equilibrium. And this is a silver. Solve for X. Okay, this approaches 0. The X that I have is 8.3 times 10 to the negative 11. You see, this value is much smaller than this value simply because of the common ion that's already there. Number 3, you want to look into which salt would dissolve better in nitric acid. Now, remember, if you have lead sulfide, when it dissolves in water, it will give you lead ion and sulfide ion, and this is a strong base. It will react very quickly with the acid, nitric acid, and produce weak weak acid, and you know weak acid doesn't ionize back that easily. Now versus if you have lead chloride. Okay, so this it will give you lead ion and then two chloride ions. This chloride ion will react with the H plus from nitric acid. And what does it produce? It produces hydrochloric acid, which is a strong acid, and ionize right back at this. So it's not going to make any difference. Okay, so in which really different from the um, lead to sulfide, because lead to sulfide, the sulfide ion react with this, so it produces weak um, weak acid, right? So that means that it doesn't ionize back. The sulfide get consumed. So because the sulfide get consumed, this reaction here has to produce sulfide to make up for the lost sulfide. Therefore, the solubility of sulfide, lead sulfide, will be higher than that of the lead 2 chloride. Same thing over here, okay, because if you dissolve silver iodide will give you Ag plus and an iodide ion. Iodide ion react with H plus, give you hydroiodic acid, which is a strong acid. It will ionize right back. Now versus silver carbonate, it will produce as carbonate. And you know how carbonate will react with the acid to produce water and carbon dioxide. And you know that this reaction, the K value is super big. So that means the carbonate keep on getting consumed by this second reaction. And therefore, this has to supply the carbonate. Okay, keep on supplying the carbonate. Therefore, its solubility will be high. And then for this one, you see the hydroxide here? Yes, this hydroxide will react with the H plus from nitric acid. So this keep on getting consumed, sucked up by this reaction. So therefore, the aluminum hydroxide has to keep on dissolving to make up for the loss of the hydroxide that get used up by doing its reaction with the H plus from nitric acid. So the solubility of this is going to be higher than this one. Okay. Next one, which one will be more water soluble? Again, if you see any time when you see the anion that's being produced here, and when it react with any H plus, even H plus water, and produce a weak acid, that salt will have the solubility higher than is what is predicted by the KSP. Same thing over here. There's carbonate. Okay, and you see over here the anion. This one produce chloride. React with H plus, produce strong acid. That means it's not gonna, the solubility is gonna be the same as what's predicted by the KSP. So versus this one, it produces cyanide, and the cyanide react with water, it will produce weak acid. So yes, because the weak acid stays like that, and this keep on getting sucked up by this reaction, the solubility of silver cyanide will be higher than is predicted by the KSP. Next one, you have the lead 2 iodide. Okay, KSP is given, and the concentration of lead is found to be 1.1. Therefore, the concentration of iodide will be double that quantity. Plug into expression. Don't forget to square still. The Q that I have is equal to 5.3 times 10 to negative 9. You see that this Q is lower than the K, slightly lower, but still lower. So therefore, more of lead 2 iodide will dissolve. Okay, you will not see precipitate in the bottom of the flask. Okay, I'm gonna stop this part here. Okay.